Welcome to Gleaner Country and a slide tour of the combine factory in Independence, Missouri. We recognize the need to continuously improve the quality of our product. And rather than reinvent the wheel, we turn to the American that helped the Japanese with quality after World War II, Dr. Deming. We are learning how to apply Dr. Deming's 14 points daily. We are teaching a 40-hour course in statistical process control to all of our employees, and 1 week out of each month is used to teach the same course to our suppliers. Statistics is a tool which allows a machine operator to control the variation from part to part in order to improve the quality. We have moved from an MRP system of parts control to a just-in-time system that we call COP, control of parts. The new system is a visible pull system that signals the user to pull parts from manufacturing and also signals manufacturing to produce more. The old MRP system was a push system. We produced parts in large quantities and stored the parts in these 4x4 steel containers. Today, we are using the small plastic container versus the large steel tub. Manufacturing was set up, as shown in this old slide, with steel containers for raw materials and finished parts at each machine. Today, we are storing parts in small containers in specially designed roller racks. The racks are designed to maintain parts in a queue to facilitate the use of statistical process control. The old and the new. Expensive fork trucks were required to move the large steel tubs. The small containers are moved with manual push carts. Hardware is also moved in 4x4 tubs. Today, hardware is received and stored as you see it. The COP parts control system permits the storing of all part numbers required for all product models in an operator's work zone. This has permitted us to assemble products in a mix. As you can see, we have all models in our final assembly line at the same time. This permits us to react quicker to your requirements, to customer demands. COP also makes all current parts available at any time for service. We are working on setup time reduction on all of our machines to improve quality of parts. As we reduce setup time, the variations from parts in process, setup to setup, is reduced. This results in parts being closer to the same setup to setup, which results in customer-perceived quality improvement. Through statistical process control, we identified our shaft manufacturing as a problem. This centerless grinder was specifically purchased to reduce our variation in shaft diameters, which in the past had contributed to bearing failures. This heat treat machine is designed to harden shaft splines, spindles, rasp bars, and other parts to engineering specifications. The numerical control mill drill is a machine that gives us greater flexibility through reduced setup time. The machine itself is tape-driven, and our experience with machines of this type has reduced our setup time from 72 minutes to less than 8 minutes. Our goal on setup times is targeted for single digits. Again, through SPC, we found considerable variation from drive axle to drive axle. So, this numerical controlled machine was installed last December to reduce variation of the mating surfaces of our load-carrying axle. By machining the mounting pads of the axle, we ensure parallelism squareness of the total combine. This numerical control punch is one of 7 utilized at Deutz Allis. This particular machine has a turret which holds 52 different punches and uses a plasma burning unit. This machine will provide quality parts with a 3-minute setup time. Prior to painting, parts run through a phosphate machine. This machine washes or cleans the parts and applies a phosphate coating. This coating provides a rust inhibitant as well as providing a surface that gives paint adhesion. After the wash and phosphate cycle, parts are then primed. The prime paint is used as a base coat, providing a seal against rust and for better paint adhesion. Again through SPC, We found considerable variation from mainframe to mainframe. So we purchased this end mill to machine the horizontal and vertical surfaces that mount to the already machined surfaces on the load bar axle. This has reduced assembly time, reduced alignment problems, reduced bearing failures, and provides a more consistent product to our customer. The first stage of the assembly process of a rotary combine is on the rivet line, where internal sheet metal is fastened to a painted mainframe. The main frames and all other large assemblies are measured and the data is charted. The statistical data gathered is used to direct us to modifications in processes needed for control. As solutions to problems are found through SPC, appropriate action is taken. A square frame will add many years of service to the Gleaner rotary combines. Belts, bearings, and shafts and drives will have improved alignment, and improved alignment will give longer life. The completed load bar axle with wheel ends is produced in a manufacturing center and transported by pushcart to the final line. The mounting pads on this front axle, as on all front axles, have been machined to provide alignment, parallelism, squareness within the combine. The assembly of the processor is a totally dedicated feeder line where welding and subassembly flow into a dedicated product area. Note that the chrome cages and chrome concaves have improved wear surfaces that give longer life to the processor unit. The cylinder is also dynamically balanced in this area after assembly to reduce vibration. The next step in the assembly process is the mounting of the deck assembly or operator's station. The engine is installed to the platform deck as a subassembly, with rear shielding attached prior to actual mounting to the mainframe. All quality checks along the assembly line are operator-controlled to provide a higher quality product. Any operator can shut down the line at any time for quality. As the rear hood is attached, we see the beginnings of a finished unit. Line assemblers are adding belts and so forth. A major advantage today in the assembly area is the COP material control system, which by design places at least 2 containers of finished products within easy reach of the line assembler for all products built. By building a model mix, assemblers build all models at least every other day instead of running in large batches. This maintains training in each model, which results in improved quality. Assembly of the grain bin and fuel tank assembly is done on mobile fixtures that are pushed to the final line. This assembly process reduces the number of in-process bins to 4. All sub-assembly areas are producing parts on assemblies in a mix in sequence with the products on the final line. After final audit and touch-up, all units go through a test run. Adjustments, if required, are made by the technicians, and feedback is provided to the assembly operators to correct problems found so problems will not repeat. Families of parts requiring similar machines for finishing have been identified, and we are manufacturing those parts in manufacturing centers today. All machines necessary to take a part from the raw material state to a finished part are installed in a confined area and make up a manufacturing center. This allows us to reduce inventories of parts and permits improved monitoring of the process through SPC. The header line is designed to set up and produce mixed model quantities of both grain heads and corn heads in any model on any given day. The grain heads are started on a feeder line to the south of the main header assembly line. The corn heads have a subassembly feeder line for row units on the opposite side of the line from grain heads. Row units are marshaled at the beginning of the line, where they are installed on roller conveyors. A mixed mode of assembly means that we could have 3 grain heads of various configuration, a corn head, another 2 grain heads, and corn heads on the line. By operating in a mode such as this, our workload is leveled. Corn heads require more labor than grain heads per unit, so by mixing the line, we maintain our labor force and are able to balance the workload much more efficiently. This also maintains training in all models. By the racking, which you see, we have a visual parts control system. Or on special carts when parts are too bulky to store in containers. The idea here is to have just enough parts at the line to maintain our daily volumes. Since every part required is within a very short distance from the point of use, the assembler walks less and is much more efficient. EI, employee involvement, plus COP, control of parts, plus SPC, statistical process control, equals quality. Quality as perceived by the customer. Because through all of the process, we are listening to our customers and taking appropriate action to support our customers' needs. Our goals at Deutz Allis Combine are simple: to build the highest quality combines in the world and to take care of our customers. To accomplish these goals, we must be market-driven and stay close to our customers. New communication links with our dealers and customers have been established to ensure that Deutz Allis Gleaner Combine provides the products and services to meet the needs of our customers. We meet with dealers regularly. We have customer and dealer plant visits regularly. We have established the Plant Pal program, where an employee talks with a customer with some regularity to obtain feedback on our products. We do have a constancy of purpose, and it is quality.